Well, hello there everybody, this is a True Nerd here, and we are going on with the third part in my little series here on building a robot. This little chapter here is about powering your robot, so you gotta kind of choose what it is you want to do in terms of powering your robot. What I have here is, this is a very common RC battery. This is a lithium polymer battery. These have an extraordinary amount of energy in them. They will, they're pretty good little batteries. They will, for a standard little robot, it'll last hours and hours and hours and hours, and you can recharge it. I can't really, aside from if you run them out, then that's not so good. But the only thing is you have to have a charger, and that's the only caveat to that. Another thing you can do is, you can use, I didn't put batteries in here, but alkaline batteries. You can use a holder just like this. You can put it on the underside. Only thing is, unless you use rechargeable batteries, which you can buy them in lithium ion batteries. This size, actually, I forget what the actual size is. I might put it up on the screen here. And but they are basically double A's, and they are rechargeable. But except they're double the voltage, or more than double the voltage, unfortunately. One of the things you have to remember is you probably want to have your robot more than 5 volts. So something like this would be 6 volts. That would be adequate. You'd want to be careful about hooking it up directly to an Arduino or, what do they call them, little Sparks or whatever, or a Raspberry Pi or anything like that. You would not want to hook this directly into it. That's why we have to really consider certain things like how are we going to convert the power. What's going to drive the motors? Are we going to drive it directly from here, or are we going to drive it from our regulated voltage? One of the problems with driving motors from regulated voltage is that, generally speaking, when you have a regulator, you have a limited amount of current you can use. So that can cause problems, or overheating, or just plain old stopping. Let's take a look at some of my options that I use regularly in a situation like this. Well, anyways, these are your bog standard tip, or your bog standard TO220 power regulators. You put power in, and out comes, and while you put power in at a certain voltage, usually over 6 volts, for low dropout at 5 volts. 5 volts will work for the 3.3 volts. You want to consider certain things like what kind of sensors are you going to put on it. So you have to go, well, how much do those draw? Are you going to put lots of those ultrasonic sensors? Are you going to put a camera on it? How much power does the brain draw? Like, I'm calling it the brain, but the microcontroller or whatever you're going to put it on, or put on it. What does that draw for power? That's a consideration, because these basically, and also another thing to consider is how much more voltage do you have than your output voltage. Let's say you have 24 volts going in, and you're going to draw quite a bit of power from that. Well, these boys are going to get hot because they drop all of that in resistance. One of the things that I look at sometimes is I use one of these guys, and you can buy these off eBay. I mean, for a simple project like this is actually quite ideal. You can adjust the voltage. The input voltage has to be a little bit higher, about 6.5 volts, but you can output it to 5 volts. It'll give you, I believe, 3 amps. It'll output 3 amps of current quite happily. It's switching, so it doesn't waste all that energy. I mean, there is some waste, but based on what I've been able to see, I mean, it doesn't waste a whole hell of a lot. So these are well worth using in any situation. And yeah, here's another set of little modules. You can buy these off eBay relatively inexpensively. You know, I haven't tested them personally. These are adjustable. It says 3 amps. I doubt the veracity of that. I would say probably 1 amp. But then again, I haven't tested it. Maybe I'm wrong. But just judging by the way it looks, the size of the coil on it, I would say 1 amp is your tops. And finally, an oldie but a goodie. This is the PT 5105. Oh boy, I got this boy sealed. I forgot all about that. Okay, this is the PT 5101. That's a switching regulator. It's basically pin for pin, exactly like the first few I showed you. Centers ground, in, out, and yeah, it works exactly the same way. Obviously you want some ripple caps and stuff, but yeah, except this one's switching, so you can go up to 1 amp. So something to consider is now that we have power out of the way, well, not out of the way, but we have some power, we need to know how we're going to drive our motors. Now, we can do this, we're going to need to know this because this is probably one of the first things you want to get working on your robot is, how do I move? So let's start with one motor. I mean, you're going to have to do this to both, but we want to get one motor working. So let's just say I'm going to go like this, and here's our happy motor. Here's another one. Here's our happy motor. Now these are two different scenarios. Let's say I want to turn it clockwise. Well, what I'd have to do, let's say in this case, to turn it clockwise, I have to have negative over here and positive over here. Let's say to do the opposite, obviously, I want to rotate it the other way. I got to go negative over here and positive over here. So how do you do that? How do you switch those sides? Well, let's take a look at a little device called the H-bridge, and this is generally what you will find either on eBay, on any kind of Chinese little store for robots, or you'll even you can build this out of transistors, or relays even. You can build this yourself if you have the time and the energy. Yeah, you can build it yourself very easily. But this is the basic gist of it. Let's take a look at this. We have a motor, and it's called an H-bridge for a reason, because it's depends on how you arrange it. So we have a motor here. Now we want to be able to switch sides at any given time. So I'm going to go like this. I'm going to give it 4 switches. And those have right. That leads to there. That leads to there. Beautifully illustrated. Beautiful. Anyways, so these are all open. No current can run through these. So let's from this terminal, I want to be able to have negative, and I want positive over here. On this terminal, I want to have negative. Right, so these can be actually joined. These can be joined and positive. So it doesn't look like much, but let's label these. Let's go 1, 2, 3, 4. Right? So let's say I want to get this guy going clockwise. Let's say this scenario applies to this, and this is the one. So negative to positive makes it like this, and negative to positive makes it like this. So I want to make it go clockwise. So what do? I will turn on, oh, I want to go clockwise. So I know negative has to go to this side. So I'm going to close switches 1 and 3. And then the current can flow through here and out here. Right? That will be clockwise. Let's say I want to go the other way. I want to go from there to there. So let's follow the current. Let's go like that. So I want it to go the other way. Let's go switch 4 and 2. That's counterclockwise. Okay. So there we are. We're counterclockwise. Now, one of the problems is you got to be very careful. You have to have a delay between when you switch from clockwise to counterclockwise. You can't just do it instantly, because even on transistors, in some cases, there will still be current going through. The gates may still be charged, but especially if you make it out of a relay, they will still be connected. And what happens in either of these cases, when either 1 or 2 or 4 to 3, right? Any of those scenarios occurs equals fire. Oh, that's a beautiful fire. Well, hot. It's going to be a short circuit. So that's one thing to consider. You will need 2 of these H bridges to control 2 motors. If you decide to make 4 motors, obviously you need more. What I buy is inexpensive stepper controllers. And generally speaking, stepper controllers are made up of 2 sets of coils. So they can be run in reverse. So a stepper motor controller, such as that, it can run 2 motors. And it can run a stepper motor, or it can run 2 DC motors. And you can output pulse width modulation through it, where, let's say you want a motor to run slower, instead of constantly feeding it power, say that's 5 volts, well, we feed it power a certain amount of time per second. Let's say half of it, so 50% of the time it's on. I mean, it depends on the frequency you want to use. A higher frequency to a motor tends to waste energy. Lower frequencies, it gets choppy. So really, that's a design decision on your part. There's also these, I believe they call them step sticks or something, right? You can also use those, I believe. I have seen them used for that purpose. So anyways, I mean, there's lots of tutorials out there showing H bridges, showing motors, and showing duty. People have done that in depth that honestly puts me to shame. But this is a more general little video. So anyways, you guys have a good day or night or whatever it happens to be, and keep on building. Join me for my next video on the robot build. Good night.